In prior lectures, we've looked at pointers, starting with pointers to simple types like int or char, and then pointers to structs, and ultimately pointers to pointers and pointers to functions. We'll extend that trend in this topic, starting by looking at how multidimensional arrays work in C in this segment, and extending that in the next segment to pointers to arrays. So first, let's do a brief review of two-dimensional or 2D arrays. Now, almost every language lets you declare an array whose elements are arranged in rows and columns, visualized as a grid, as in our diagram right here. To identify an element in the array, you use two bracketed indexes, like here, 2 and 3. The first one identifies the row, and then the second one identifies the column. Now, per usual, any integer expression may be used for the indexes. To declare such an array, you give two bracketed values, constants, after the array name in the declaration. In our notes, you can see that those are pound-defined rows and cols to be 4 and 5. Now, you may also be familiar with 3D arrays, but if not, consider line 36 here of the example code. Giving 3 dimensions after the declaration of movie here makes it a 3D array. And this is best visualized as a series of frames, and that's defined as 100. I won't draw the whole thing, but frames, layers, and in each layers we have a two-dimensional rows by cols array. And so the grid-like thing down here is an example. Here are the layers, and again, I'm not going to draw all 100 of them. And then there's your rows and columns for each one. And of course, indexing this similarly requires 3 bracketed integer expressions in order to identify both the layer, the row, and the column that you want. Now, there are many uses for multidimensional arrays, especially in graphics and physical simulations. For instance, if we imagine storing small images as rows by cols arrays of pixel intensity values, then a 3D array, well, first then a 2D array can represent one image, and then a 3D array comprising frames such 2D arrays might store a movie of such images, one per layer. In rare cases, you might see more than 3 dimensions, and in fact you can add as many dimensions as you can keep track of simply by adding more bracketed indexes. Now, that much should be review, but what might be new to you are lines 31 through 34 of our example code, where we initialize image via brace notation. When you initialize a 2D array this way, each row gets its own set of braced values, and the rows are collectively separated by commas and enclosed in braces, outer braces that go outside the entire collection of rows. Now, you may actually dispense with the inner braces and simply list enough values to fill a 2D array all in one brace pair. The values go into the array in row by row order. But the inner braces emphasize the idea that each row stands as a smaller array in its own right. And that's something that is essential to understanding C multidimensional arrays. In reality, C has no multidimensional arrays. It has only single-dimensional arrays. Well, then, what have we just been discussing for the past several minutes? What are image and movie if they're not 2D or 3D arrays? They're arrays of arrays. When you think about it, computer memory is just a long sequence of bytes. It doesn't let you store values in grid arrangements, even though we may find it convenient to visualize them that way. So, how is image stored in memory? Well, C, like all other modern languages, stores two-dimensional arrays row by row, with one row following another in memory, as shown in the diagram here. This is termed row major order. Now, we've seen arrays of compound types like structs. Extending that idea, a 2D array is simply a one-dimensional array, each element of which is a smaller one-dimensional array. C views image as a 4-element array of each element of which is a 5-element array of ints. You can think of it as an array of rows, if you like. There's question 1. From this viewpoint, the two index values on line 38 here do not both index the same array. Why not? On what array does the first index, the 2, operate, and what about the second index? Going back from a pause, well, the first index operates on image, and that chooses one of the smaller arrays that are the elements of image. In fact, it chooses this one here. The second index operates on that selected subarray, not on image, and it chooses one integer within the smaller array, and in fact ultimately chooses this integer right there. Now this is more than just an abstraction. The C syntax and semantics relative to multidimensional arrays are only clear if you see them as arrays of arrays. Note, for instance, the line 38 comment. The syntax, image bracket 2 in parentheses, then bracket 3, is allowed because the 2 and the 3 are distinct indexing operations, operating on two different arrays, as we just saw. And on line 39, you see that we may treat an entire row or subarray as an entity in its own right. We are getting the size, for instance, of the entire array or of one row of the array here. And briefly here, question 2. Are the parentheses in this line 38 comment meaningful, or are they just redundant? And why exactly? Coming back from the pause, answer 2, per the C precedence table, the two bracket operators have equal precedence, but they associate left to right. So the first index would be done first. The parentheses, thus, are redundant. Now, I brought that up because this is a good time to review the relative precedence of the bracket, unary star, the dereferencing star, and the parenthesis function call operators that are on the top two rows of the precedence table. We'll be dealing with those precedences very closely in the upcoming discussions. Question 3. So, if this is the way we're looking at multidimensional arrays, then what is a 3D array like movie an array of? Again, returning from a pause, it's an array of arrays. Let's try to diagram that here. So in the next segment, we'll look at the pointer types associated with multidimensional arrays and how multidimensional arrays are passed as parameters. There. Each element of the one-dimensional array, movie, is a two-dimensional array in its own right, itself an array of arrays. And we're looking just at the first element, big 0 there, and then the second element I managed to get a little bit of it on the screen, but not much. And you can imagine the other 98 of them extending out quite a distance there.